Well, welcome back. This is the lecture for Chapter 1. I will try to make these relatively brief. The goal of this is to give you my impression and my insights into the material in the book. What I talk about won't be necessarily exactly the same as what's in the book, but it'll be fairly close to it. So let's get to it. Where do people live? As you can see by this graph, most people, 59.9% of the population, lives in Asia. Europe, Africa, South America, North America, and so on make up the rest. But the bulk of humanity lives in two places, in South Asia and East Asia. What's changed over time is pretty dramatic. The Earth's population was relatively stable for many thousands of years, well below 1 billion, until about the year 1800 or so, when it exploded. And the population has geometrically increased in size, and it's thought to maybe peak out sometime in the next several decades at around 10 billion or so, although that number is disputed. It really depends on a lot of situations. One of the things that we'll be talking about in this class is that there's been a rapid decline in fertility rates in most places in the world, which actually may make this 10.5 billion number a little bit optimistic. What caused this incredible rise in the human population? The Industrial Revolution and technology, especially technologies that kept people from dying, and especially children from dying. Here's another chart that looks at the human history of population. And again, you can see the specific technologies here listed that really contributed to this geometric rise. Primarily, the things that really affected the death rate, especially for children, were public health measures more than anything else, and medicine. Having clean water is huge. It keeps a lot of children from dying of dehydration. Here's another chart that looks at the same phenomena. Again, you can see that generally speaking, this is being displayed the same. The number of people really dramatically increased at the dawn of the Industrial Revolution. Beginning in the places where the Industrial Revolution happened, which was at first England, then spreading to the rest of Northern Europe and North America, and eventually to the rest of the world. Another way to look at it is doubling time. You can see it took all of human history, tens of thousands of years, hundreds of thousands depending how you count it, for humanity to reach 1 billion people around 1800. But then it only took 130 years to get to 2 billion, 30 years to get to 3, and so on. The doubling time has increased as there are more humans on Earth, there are more babies on Earth. And so even if the growth rate slows down, just the total number of people that are now alive continues to create a huge number of births. So this doubling time is something we use in population studies quite frequently. The number of years in which a population reaches twice its size. It's calculated using the rule of 70. Basically take the number 70 divided by the growth rate per year. So here's some examples of doubling time depending on the growth rate. So you can see as the growth rate decreases, the doubling time increases. The United Nations groups countries this way, and these categories are really quite important for our class. It's least developed countries in red. You can see mostly sub-Saharan Africa. Developing countries in orange, which make up Latin America, much of South Asia. Economies in transition, primarily Eastern Europe and the Russian Federation. And then developed countries, which include North America, Europe, Australia, New Zealand, Japan, and a few others. Now, if we look at population projections over time, you can see using what's called a population pyramid, the world is going to change demographically, is changing demographically quite dramatically. Now, these population pyramids are fairly straightforward. It's age groups here, or age cohorts, and then males and females on one side and the other, and then this is numbers of people, population in the millions. So here's India and China in comparison. Now you can see the reason why China has such a jagged pyramid is because it's had a lot of turmoil in its history. It's had revolutions, it's had cultural disruptions, far more than India has. So let's take a look what happens over time. You can see that the pyramids are changing more to look like columns. By 2050, the number of children is going to be smaller, especially in China, than the number of adults. And this is a profile that's more associated with developed nations. As nations develop, they stop having so many children, growth rate slows, and the pyramid becomes more like this. In extreme cases, it can actually invert, and the bulk of the population is actually in the middle age. Here it is again. Where are the growth rates really high still in the world? Primarily, it's Africa. You can see here, more than 3% in these countries in deep red. And the rest of the world is seeing a much lower population growth. Near zero or below zero, in fact, in many places. This is continuing to develop. More and more of the world is going into the green category. Even Africa is slowing down, even though relatively it's much higher than the rest of the world. Developed, less developed, least developed are categories that we'll be exploring quite extensively. Let's switch a little bit now to a different scale and look at urban growth in a regional sense, much smaller scale. And you can see here in San Francisco how the city grew over time, or the urban land use. This has been a phenomenon that's been happening throughout all of modern history. This movement from rural to urban is still happening powerfully today in many places of the world. Here's a look at some of the largest conglomerations of urban areas in the world. Tokyo leads the way. Delhi is catching up, and there are many other cities in the world that have more than 20 million people in their surroundings. This leads us to looking at a very common and popular model in demographics called the demographic transition. There are 4 stages, sometimes 5, associated with this model. Stage 1 is high birth rates, high but fluctuating death rates. So in other words, the death rates and the birth rates are quite high, about the same level. So there is no growth. You can see the growth rate is fairly flat. This is really what most of the world was like until about the dawn of the industrial age, when some countries, starting with England, began to get into the stage 2, where death rates in the green line here began to significantly decline. Much of this is due to public health measures, having clean water, having medicine, eventually things like vaccinations and antibiotics, keeping people alive. So that led to a rapidly increasing growth in population, because the birth rate continued to stay high throughout this period. When the birth rate finally begins to drop, then we head into stage 3. Now all of a sudden you're starting to see that the population growth is starting to taper off as these 2 lines approach each other. When they do approach each other and the population does taper off and flatlines again, then we're into stage 4. Stage 5, which is not on this chart, is when the population begins to decline, when the death rate actually becomes greater than the birth rate. So the key terms that we need to be familiar with are the birth rate, and it's usually measured number of live births per 1,000 people per year. Death rate, number of deaths per 1,000 per year. And then the natural increase is basically births over deaths, or birth minus deaths. The other measure is the fertility rate. This is children per woman of childbearing age. That ranges, depending on where it's counted, somewhere between 15 and 50. And you can see again, Sub-Saharan Africa in particular has very high fertility rates still, and so do other countries in Southwest Asia. Most everywhere else, the fertility rate has been decreasing quite dramatically. Now, a lot of people talk about China's one-child policy. The one-child policy did not contribute primarily to China's decline in birth rates, because the decline in birth rates really started way back in the 60s here. And the one-child policy wasn't instituted until about 1979, I believe. It did lead to continuing declines, but it's hard to say how much it contributed to it. This policy was enforced pretty strictly in the cities, in the urban areas, not so much so in the countryside. There's a huge difference between city life and country life, between farming life and sort of urban work life, where in farming areas, children are a asset to a family. They are workers, whereas in urban areas that have child protection laws, children are economic liabilities. So naturally, people tend to have many less children in urban areas than they do in rural areas. And as the world has transitioned from rural to urban, people have naturally just had less children, irrespective of what kind of government policies are enacted. Here's a population cartogram. Basically, these cartograms are designed to show the size of a country based on that particular theme, in this case population. So it shows China and India as much bigger than they really are, and like Canada, which is one of the second largest country in the world, is actually quite tiny here. So is Russia, which is the largest country by land area in the world. What are the projections? If you look at this larger map here, or this chart, what we see is a leveling off. In this particular case, thought is it would level off around 9 billion. Now we're just above 8 now. We're about here. It looks like we're actually at least going to taper off around 9 billion, perhaps even less, as fertility rates really dramatically decline. We are not likely to see the 10.5 billion that most people thought we would just a few years ago. This is something we'll talk about more in a chapter on fertility. Much of the class is going to be devoted to looking at the movement of people. The role of immigration is tremendous in human demographics. What we've seen is that the movement of people has increased with modernity very significantly. You can see from this graph on the left that growth just from Americans would start to see us losing population around 2020. We are slated to actually have far larger increases in population in the United States because of immigration. That is, if immigration rates continue the same. As we know, they are a political hot button issue. So depending who's in power, we're going to see big differences in terms of how many people America is going to let in the next couple of years. On the right-hand side, we're seeing the migration flows. The countries that receive the most are in the deep blue: United States, Canada, Australia, much of Europe. And here in Saudi Arabia and the Middle East here, the reason why you're seeing large numbers here is because there's a lot of workers that go in to work the oil industry in these countries. And where you're seeing a decline is in Northern Asia, primarily, and some countries that are in crisis in Africa, where people are fleeing primarily in the form of refugees. Lastly, let me just show you some data issues. This map is called a shading map or choropleth map. Depending how you define the different categories of income here, the map is going to show very different visually. So this is classed by equal intervals. So the income is split equally along 5 different categories. The cities primarily have the higher incomes. The same data now is presented in quantiles. In statistics and probability, a quantile is a cut point that divides a probability distribution. So it splits the sort of data based on equal parts based on probability, the chances of a particular data point to fit into the categories. Now this is looking like a very different map, isn't it? There are several other ways of splitting up the data, which we'll get into later. And of course, the other thing we'll be looking at in this class is a lot of quantifying the data. And here's an example of that. So if you have 2 different population census and you want to estimate the population in between them, you would use this calculation. You would take the population at the start plus the months in between that you're looking into, divided by the total month in the period. Here's an example. The first census showed 1 million. The second census showed 1.2 million. the time between was 24 months, but you were interested 8 months into it, then you would plug all these numbers in and you would get the answer to that. A population projection looks in the future, so you take the population plus the rate of growth times the population to project out into the future. So if the rate of growth was 2% and the current population is 1 million, you plug the numbers in and you get an answer. That's about it for the first chapter. Please look for the assignments coming up on Blackboard. If you have any questions, always feel free to ask. You can email me, send me a message, and we can also, if necessary, meet online on a one-to-one meeting on video. Take care.